Welcome, Math 107 students, to the lesson activities for Lesson 20 on quadratic functions. Consider the quadratic function f of x equals -1 times the quantity x minus 1 squared plus 4. So this quadratic function is in the form of f of x equals a times the quantity x minus h squared plus k. Now, we were introduced to this form in this lesson, and we call this form the standard form. The other form of a quadratic equation, the general form, is one that you're more familiar with, and that looks like ax squared plus bx plus c. Remember, sometimes this is referred to as the polynomial form. Okay, so I think it's probably a good idea just to have both forms in front of you as we work through, or at the top of your page, as we work through today's exercises, just to get familiar with them. Okay, so identify the values of a, h, and k. Okay, so here's our particular function. Here's a general way we write it, the standard form. So a is equal to a -1. It's understood to be a -1 out front when you see that dash. H is +1 and K is 4. So immediately we can determine that the vertex of our parabola is 1, 4. So let's put that point in, 1, 4, 1, 4. That's going to be our vertex. Now we have to determine if this point is going to be a minimum point or a maximum point, a relative min or a relative max. In this case, it will be a turning point. We know that. We just want to see what type of turning point it is. So does the parabola open up or down? Well, since a is negative, a equals -1, we know our parabola opens downward. So we know this parabola is going to open downward. Okay, so that makes 4. 4 then is the maximum value of this function. We'll never get a value bigger than 4 for any x we plug into this function. So 4 is the maximum. So now to finish off the graph, we need to find a couple of key points. We need to find the y-intercept and the point symmetric to it, and our x-intercepts. So to find the y-intercept, we find f of 0. We plug 0 in for x, and we evaluate that to get our output. So we get -1 times -1 squared plus 4, which is -1 times 1 plus 4, which is 3. So 0, 3 is our y-intercept. Okay, and we know that our vertex, at our vertex, there's a line of symmetry that it can also be called the axis of symmetry that we can use to determine points symmetric about that line of symmetry. So in other words, 0, 3 is the y-intercept. It is 1 unit to the left of our vertex or our line of symmetry. So we know that 1 unit to the right, we will have a point symmetric at 2, 3. So we get that point for free. Okay, so we've got our vertex, our y-intercept, and the point symmetric to our y-intercept. So that's kind of fun. Okay, x-intercepts. So the point symmetric is 2, 3. Oh, I did want to point out one thing to you. Often students make the mistake, they confuse this 4 right here. They confuse this 4 with the value, the constant value right here in our polynomial form. Okay, so if we had this particular equation, let me erase that. That didn't come out too great. Oh, it's not going to let me erase it. I guess I'll have to move it up. All right, there we go. If we had our quadratic function in polynomial form, then we can find the y-intercept by just looking at the constant term. But when it's in this standard form here, you can't just pluck off the 4. It's not your y-intercept. In fact, we see 4 here is actually our highest value, our maximum value. So you actually have to do the work. It's not too much work. You have to plug 0 in and determine the output value when x is 0, which is 3 in this case. Okay, so you might want to make a little note for yourself here. Sometimes that can be confusing when you're plotting these particular quadratic functions. Okay, x-intercepts. Well, what do we know about x-intercepts? They're the zeros of our function. It's where your function is actually equal to 0. So you set your function equal to 0, and then you solve for x. And we know in this case, if we continue to draw our parabola, that we're going to hit our x-axis in 2 spots. So we want to make sure when we do our algebra here, we get 2 x values. Again, this is a quadratic equation, so we always want to be on the outlook for 2 x intercepts. Now we know we can get 1 and we know we can get none, but in this case, from looking at our graph, we know we can have 2. So I'm going to subtract 4 from both sides as my first step. And now I'm going to divide both sides by -1, which gives me 4 equals x minus 1 quantity squared. Let's move this right up here. X minus 1 quantity squared equals 4. So when we were solving quadratic equations, we spent quite a bit of time talking about how you solve this type of equation. So we know that through our square root property, we can go from this equation down to x minus 1 equals plus or minus the square root of 4 by finding the square roots of both sides. So x minus 1 equals plus or minus 2. So x minus 1 equals 2 means x is 3, and x minus 1 equaling -2 means, x equals, let me make that a little bit clearer. I got close to the edge there, so move in a little closer. X minus 1 equals -2. When you add 1 to both sides, you get x equals -1. So we've got -1, 0, and 3, 0. So now we're all set to finish our sketch off. We know that this parabola is going to go through those 5 points, and then it's going to continue down forever and ever. So again, key idea here, find your vertex, which is pretty straightforward when you have your quadratic function in this standard form. Determine whether your function opens up or down. Then find your y-intercept, the point symmetric to it, and your x-intercepts. Okay, let's take a look at another problem here. I'm going to erase some of this stuff now. Give us some more room here. Okay, so here's a quadratic function, 4x squared minus 16x plus 1,000. And without graphing, we want to figure out whether or not this function has a minimum value or a maximum. So to help you with that idea, you look at the leading coefficient here, the leading coefficient, or your quadratic coefficient. There's another way you could define that coefficient. It's the coefficient of your quadratic term. So since it's positive, since a equals 4 and that's positive, then we know we're going to have a parabola that opens upward. So we will be finding a minimum value. So let's find that minimum value. Recall that the x value of your vertex is the opposite of b divided by 2a. Now remember, you can only use this formula if your quadratic function is in general form or polynomial form, which this is. So b in this case is -16, so the opposite of -16 divided by 2 times 4 is 16 divided by 8, which is 2. So now we know the coordinates, one of the coordinates for our vertex 2. So to find the y value for our vertex, all we have to do is plug 2 in for x and find the output value. So we get 4 times 2 squared minus 16 times 2 plus 1,000. So that equals 4 times 4 minus 32 plus 1,000, which equals 984. So the minimum value to answer the question, the minimum value of this function is 984. It occurs at x equals 2, but we're interested in the output value, 984. So since that's the minimum value of my graph, my range is going to start at 984 and continue to positive infinity. So that's how you can use your minimum value to help you determine the range. The domain, well, since a quadratic function is a polynomial function, we have no limitations on the x that can be the set of x's that are the input or the domain of a polynomial function. So we just say all real numbers. We like these, all real numbers, nothing to worry about at all. All right, use interval notation to identify the function's domain and range. We've just done that. So these are some of the other types of questions you could be asked to find when you're working with quadratic functions. All right, maximizing area. You'll see no matter what college algebra book you open up, you'll see questions like this at the end of every quadratic functions section. So let's read this problem first. A farmer has 400 feet of fencing to enclose a rectangular corral. To save money in fencing, he intends to use the bank of a river as one boundary of the corral. Find the dimensions that would enclose the largest area. Boom, right there. When I see the word largest, I think maximum. And when I think of maximum, I think of vertex. So anytime you're reading things about largest, biggest, most, least, smallest, you should be thinking max or min, your vertex. It is often helpful to draw a picture to help you know how to begin to see the relationship between the words in algebra. Please make sure you describe each variable being used with a quantity statement and the appropriate units. So let's figure out what is going on here. We've got some riverbank, and we're going to take some fencing, 400 feet of it, and we're going to use the riverbank to be one side of our corral, and we want to figure out how do we maximize the area inside this corral when we have 400 feet of fencing. So this idea of 400 feet is to help us be able to write one of our variables. We got two variables here, length and width, and it helps us talk about one of them in terms of the other. That's the whole purpose of knowing the perimeter of the fencing. So remember, 400 feet is the same idea as the perimeter, but don't immediately write down perimeter as 2L plus 2W, because guess what? We only have 3 sides. So again, to start our problem with a variable, we need to define what that variable is. So let's say that L will be the length of the side that is perpendicular to the river. And that's going to be measured in feet, that length. And let's say W will be the length of the side that is parallel to the river. And that's measured in feet as well. Okay, so what do we know? We know that our perimeter will be 2 lengths plus 1 width. and our perimeter is equal to 400 feet. So this equation can be used to solve for either L in terms of W by subtracting W from both sides and dividing by 2, or to solve for W in terms of L, which is what I'm going to do because I don't want to get into fractions. And by dividing both sides by 2, I'm going to get into a fraction. So anytime you have a 1 as a coefficient, that's going to be the variable that you solve for. It's the easiest variable to solve for. So I'm going to solve this equation for W by subtracting 2L from both sides. So now I have a new name for W. It's going to be called 400 minus 2L. So I'm going to replace W with 400 minus 2L. And that represents one number, so I'm going to keep it in parentheses. So now I have the length and the width both expressed in terms of L. So now I can write my function for my area. My area is the length times the width. My width is 400 minus 2L. So I want to maximize this area, which means I have to find the vertex. And I can't find the vertex until I can put it in either the standard form or the general form. So let's multiply L through and see what this looks like. 400L minus 2L squared. Okay, so this is in the standard form, the general form, or what I typically call the polynomial form. So I know that I can find the vertex value, L, by using the formula, the opposite of B over 2A. Now be careful, this is not in descending order. So don't look for the first number as A all the time. So if you want, if you could rewrite this as negative 2L squared plus 400L. Just the little things that can trip us up. Okay, so B is 400 in both of these expressions. So we get negative 400. A is a negative 2, so we get negative 400 over negative 4, which is 100. So that tells us that our length is 100. So here we go. I'm going to replace my length with 100 on both sides. And what do I know? I know that 100 plus 100 is 200. So 400 minus 200 gives me the width, which is 200. That all adds up to 400 feet of fencing. So the dimensions, which is what the problem asks me to find, is 100 feet by 200 feet. And if they ask you what the maximum area was, then you'd multiply 100 feet by 200 feet to get 20,000 square feet. Okay. The penny drop. This is a fun problem. Suppose you're standing at the top of a 300-foot high tower and you're holding a shiny new penny. You resist the urge to throw it off the tower since that would be wrong. Instead, you toss it up at a velocity of 10 feet per second, and then when it comes down, it misses the edge of the tower and plummets to the ground below. Apparently, you figure that if it hits someone this way, gravity is to blame and it's not your fault. Mathematicians have strange humor. A local physicist informs you that t seconds after you toss the penny, its velocity in feet per second is given by this particular function. V of t is equal to negative 32 times t plus 10. So you tell me a value for t, and I'll tell you the velocity of the penny at that particular time. Note that positive velocity corresponds to the penny moving up, as it does originally when you toss it in the air, and negative velocity corresponds to it moving down, as it will eventually. The physicist also tells you that the penny's distance from the sidewalk in feet is given by this function, S of t equals negative 16t squared plus 10t plus 300. So before I even start working on any problems, I always try to draw a little diagram for myself. So I imagine here I have my 300-foot tower. So I'm up here at 300 feet. I toss the penny up in the air, and then it comes back down and hits the ground. Okay. So I just do a little diagram like that for myself. It just helps me try to visualize what's going on in the problem. So the first question says, at what time? So I immediately know I'm solving for t. At what time is the penny's velocity equal to 0? So that means I have to use my velocity function. I want to know, when is the velocity v of t equal to 0? So let's set v of t equal to 0. That's the left-hand side of this equation. And let's solve this for t. So I get negative 10 equals negative 32t. Negative 10 over negative 32 is the same as 5 over 16, and that's equal to t. So the velocity of the penny, will equal 0 feet per second at 5/16 seconds after being thrown or tossed. Okay, so the velocity is going to be 0. So you're throwing it up, the velocity is 0. That's going to happen right at this maximum value right here. The velocity at that point will be 0. Okay. At what time is the penny at its highest point? Well, if the penny's velocity is 0 at 5/16, so that's going to be when it reaches its highest point before it starts to fall down. Maybe we should get exactly the same answer for B as we do A. Well, let's see. Well, at what time is the penny at its highest point? That has to do with distance above the ground. Highest, every time I see these superlatives, highest, biggest, most, I think vertex, always, always. So let's take a look. S of t, perfect. It's in my general form that I'm used to seeing. So I can identify A is negative 16 and B is 10. So now I can find the value of my vertex, my 2 coordinates. So the t coordinate is going to be the opposite of B over 2A. And that's negative 10 over negative 32. Lo and behold, that's 5/16. Exactly the same time as the answer to A, both 5/16. So that just tells me the time that I reach my maximum distance above the ground. Now I have to find how high that is, the actual maximum height. So to find that, I plug in 5/16 for t, and I do my arithmetic to find the value of the height above the ground of my penny at time t equals 5/16. So this is approximately, when you do all the arithmetic out, 301.56. So the maximum height achieved by the penny is approximately 301.56 feet. All right. So that's how you use these 2 different functions. One answers velocity, one answers height. Now it asks, how long is the penny in the air? Well, if we go back to our diagram, the length of time, again, how long we're answering time, will be the t value when this penny hits the ground. So when it hits the ground, S of t is 0 when it hits the ground, when the penny hits the ground. So again, when we find that value for t, then we'll know how long the penny was in the air. So we set s of t equal to 0, and we solve this quadratic function. To make life a little easier for me, because as you can see, A, B, and C here in our to solve this quadratic function with the quadratic formula, those are pretty big numbers. So anything I can do to make this a little easier, I'm going to do. So I'm going to divide both sides by -2, everything on both sides. I could have picked +2, but I always like my leading coefficient to be positive when I can. So that's just my little sort of strategy. So -16 divided by -2 is 8t squared, and then 10t gets divided by -2 as well, so that's -5t, and then 300 gets divided by -2 as well for -150. Okay, so I have a equals 8, b equals -5, and c equals -150. So I'm solving for t, so I don't say x equals, it's t equals. So t equals, the opposite of b is 5 plus or minus the square root. 5 squared is 25 minus 4 times -8 times -150. Okay, I just caught myself making an error, which is easy to do with the quadratic formula. I'm moving so fast that I didn't notice that a is +8. So let's rearrange this here to make it an 8. Okay, so it's b squared minus 4ac. Now that looks better, over 2 times a. So t equals 5 plus or minus the square root. And when I multiply this all out and add it to 25, I'm going to get 4825. I'm subtracting a negative number, which is the same as adding. This ends up being 4,800 when I multiply it out. And it's a -4,800. So 25 minus 4,800 is 4,825 all over 10. So to help make this a little bit easier, I can pull a square root of 25 out of here. So the square root of 4825 is the square root of 25 times the square root of 193, which is 5 square roots of 193. So this becomes 5 plus or minus 5 square roots of 193, all divided by 10. Oh, I can't believe I did that. Look, I've made so many mistakes with this quadratic formula. I can't believe it. Look, I have 2 times 5 on the bottom. It's supposed to be 2a. So I'm not going to do this entire thing all over. I'm just going to admit my mistakes here and correct them. Okay, and I'm very sorry. I hope I didn't mess you up too much. Okay, so there we go. So that's the exact 2 times that a penny would hit the ground. One would be not relevant to our problem because it would be negative. I believe it's negative. Let's see. 5, take away 5 times the square root of 193 over 16 is one of our answers. And then 5 plus 5 square roots of 193 over 16 is our other answer. So let's take a look at 5 plus 5 square roots of 193 divided by 16, and we'll get an approximate time. So we have 5 plus 5 times the square root of 193 equals divided by 16. And that's about 4.654 seconds. So approximately 4.654. And let's see what this one is. So let's clear this out, and we have 5 take away 5 times the square root of 193, and that's all divided by 16. Yep, and that's a negative number, so this is not useful in the context of this problem as a solution. So how long is the penny in the year? Answer the problem. It is in the air for approximately 4.654 seconds. So notice I made quite a few mistakes here because I didn't put my A, B, and C right above my formula, and I was hurrying. And this is often what happens when students use a quadratic formula, is it just lends itself to errors if you're not really careful and you really take it nice and slow. Okay, so how fast is the penny going when it hits the ground? Okay, so how fast is it going? Oops, that's velocity. So when it hits the ground, I know my time is approximately 4.654. So it's negative 32 times 4.654 plus 10, which is approximately equal to negative 138.92. And remember, this is in feet per second. So this tells you that its speed is, or velocity is 138.92 feet per second, and it's moving downward. That's the difference between velocity and speed. Speed is the absolute value of velocity. Speed doesn't care or makes no reference to direction, whereas velocity does have reference to direction. All right, so I haven't converted that to miles per hour, and to do that, you take the negative 138.92 feet per second and you multiply it by 30 over 44, and when you do that, you get approximately 94.7, negative 94.7 miles per hour. Whoa, that's pretty fast. Okay, so that was kind of a fun problem. You learned a little physics, I hope. All right, and finally, we have this basketball problem that I got out of a book called OpenStax, College Algebra. And this is, it says, find the standard form of a quadratic equation for the path of the ball. And does the shooter make the basket, yay or nay? So here's a basketball being shot, and the grid's been superimposed. We know 1 point on this parabola right now, 0, 0. So this is -1, -2, -3, -4, -5, -6. And this point right here, which is right in the middle of our basket, would be -7.5. So how do we determine if the shooter is going to make the basket? Well, first of all, let's take a look at what we're being asked to find. It says, find the standard form of the quadratic equation. So the standard form looks like this: f of x equals a times x minus h, the quantity squared, plus k. So right now, this quadratic function has a as an unknown, h as an unknown, and k as an unknown. So we've got to start finding the values for some of these variables here. So let's see, we can look at the photo of the basketball and determine the vertex. So let's see, we're going 1, 2, 3, 4 to the right, to the left, and we're going 1, 2, 3, 4, 5, 6, 7 up. So our vertex is -4, 7. So let's throw that into our standard form. A times x, take away a -4, quantity squared, plus 7. So that gives me f of x equals a times x plus 4, quantity squared, plus 7. So now I'm going to call this y equals a times x plus 4, quantity squared plus 7. So you can see how we proceed from here. So this is like when we have a straight line and we know our slope and we know a point or two on our line and we have to solve for the value of b. So we always take a point that we know that lies on the graph and we plug that point in to solve for the value we don't know. So here, all we need to finish off the equation for this parabola is the value of a. This is like number 4 in our demo. Okay, so do I know a point on here? Well, I know the vertex, but I need another point. And lo and behold, thank goodness I have the origin. And the origin has a y value equal to 0 and an x value equal to 0. So now I can solve this equation for a. So I have 0 equals a times 4 squared plus 7. That equals 0 times 16a plus 7. Negative 7 equals 16a, so a equals negative 7/16. So now I have everything I need to write the standard form for this particular quadratic function. So the a value is negative 7/16. I put my vertex in, and so here is my function. Now, another little mistake students make a lot of times is they forget to put the square on the quadratic function. I don't know what it is about this particular form that students forget that, but they do. So you may want to make sure that you have the 2 there. So how do we answer the question? Well, we want to see what the height of the basketball is right at this point right here, negative 7.5, to see if this young person made the basket or not. So let's give ourselves a little space here. We've got our function now. So let's see, what is the height of my basketball at negative 7.5 on my grid? So I get negative 7/16 times negative 7.5 plus 4 quantity squared plus 7. When I do out the arithmetic, I get about 1.64 feet, which means when the ball comes down, it's going to be at 1.64 feet. And the height needs to be roughly right here about 4 feet. So he does not make the shot. Does not make the basket. So that's a sad face. Okay, that does it for our activities. Please let me know if you have any questions and I'll be glad to help.